Welcome to another Physical Sciences 3 lecture. This time we are on page 11 of the Criterion 5 booklet and we are looking at equations of motion. So the equations of motion are used in this course to apply to motions in straight line, two directions, under constant acceleration. So constant acceleration. The quantities used in these equations are shown in the table below. So we have displacement, initial velocity, final velocity, acceleration, and time. Okay, and I call these ones SUVAT. So SUVAT. So I call it SU. That's a V. SUVAT. SUVAT. And we use these when we have a body accelerating. So there are four equations here of motion associated with these quantities that can be used to solve problems. In some situations, it will be necessary to transpose or combine these equations in order to get the final answer. So transpose means rearrange the equations. So make another one of these variables the subject, or combine these equations in order to get the final answer. The equations are shown below there. And I also just want to show you the information sheet, which is on Canvas, and you'll be allowed this in the exam. So it's very important that you get familiar with this information sheet. As you can see here, they've actually got all the symbols that we use and the names of the symbols and also the units that go with the symbols. There's many more equations that we're going to learn, as you can see throughout, and there's 7 pages of this stuff. So there's also chemistry things in this information sheet. And as you can see, the equations of motion are right at the top here, right there. So try and get familiar with that and use this while you're solving the problems. Okay, so we have some steps here for using motion equations. So particularly when an object is accelerating, you can do these when there is no acceleration as well. However, as we'll see in the first few examples, it's not really necessary to do all these steps. But define a direction as positive, which we have already kind of started to do. List 5 variables from the table. So the 5 variables are these ones, the SUVAT variables. Assign values for all known variables as positives or negatives as required by your defined direction. So assign values to all known variables. So it's important to identify those ones. Identify the variable you are trying to find. So I usually say whatever variable we're trying to find. I assign a question mark to that. Choose an equation that consists of what you're trying to find and known values. Okay, so you just have to choose one of the 4 equations up there. Complete the calculations and then state your final answer interpreting the sign. Alright, so before we start doing any examples, we just want to highlight that it is often necessary to convert from kilometres an hour and metres per second. The conversion factor is 3.6 and used as indicated below. So I'm just going to add something up here actually. So when we assign values, we also want these to be in SI units. Okay, so you always just want to have things in SI units, then you know that they work. So these equations work in SI units. Okay, if you assign everything SI units to start off with, you know those equations are going to work. So that means that we want to use meters per second for velocity and initial velocity. Okay, so if a problem gives you kilometers per hour, because that's the unit that we're used to using for speed. So if someone tells you my car was going 100 kilometers an hour, we need to be able to know how to change that to meters per second. So if we are given a kilometers per hour value and we want to change it to meters per second, we need to divide by 3.6. And the way I remember this is kilometers are bigger than meters per second. So we're going from big to small, we need to divide. And if we go the other way around, if we're given meters per second and we want to tell someone in kilometers per hour, we need to multiply. So we're going from something smaller to something bigger, so we multiply. Okay, that's just a simple rule for me to remember which one to use and when. The reason you might want to go from meters per second to kilometers an hour is similar to the reason we want to go the other way, but you might do all your calculations in meters per second, but it's pretty hard for us to know intuitively how much meters per second is, because our cars give us kilometers per hour. We're very much better at saying, well, we know that 100 meters per second is quite fast. 100 kilometers per hour, sorry, is quite fast. But what is 20 meters per second? Is that fast? We're not sure. So if we know something's kilometers an hour, we generally know that we can just generally tell whether something's quick or not. Okay, so the first examples here are questions in which velocity doesn't change. Okay, so acceleration is equal to 0. All right, so A is equal to 0. So these are generally straightforward. Generally straightforward means generally quite easy, and can be solved using the formula V equals S over T. I'm just going to move that away. Move that up a little bit. V is equal to S over T, without the need to apply the full steps shown on the previous page. Okay, so the first thing we want to do is convert 80 kilometers to meters per second. Okay, so remember, if we're starting with kilometers per hour to meters per second, we need to divide by 3.6. So 80 kilometers per hour is equal to 80 divided by 3.6 meters per second. And when we put that into our calculator, 80 divided by 3.6 is equal to 22.2 meters per second. 22.2 meters per second. Okay, so a velocity of 20 meters per second to kilometers per hour. This time we need to times it, so 20 meters per second times 20 meters per second. I'll want to undo that one. Is equal to 20 times 3.6 kilometers per hour, which is equal to 72 kilometers per hour. And you can check that with your calculator if you like. Okay. So the constant speed, i.e. no acceleration. So calculate the average speed of a runner who covers 42.195 kilometers in 2 hours and 16 minutes in 40 seconds. So firstly, we want to have that in meters per second, and then we want to have it in kilometers per hour. Okay, so in order to work out the average speed, so we have speed is equal to distance over time. So we know what the distance is equal to. It's equal to 42,000.195 kilometers, but I want that in meters, so we need to times by 1,000. So it's going to be 42,195 meters. Okay. The time is equal to 2 hours, and I want to convert that to seconds. So there's 60 minutes in an hour and 60 seconds in a minute. So 2 times 60 times 60 plus 16 minutes. So 16 times 60 seconds plus 40. And that's equal to 8,200. So we can put that in our calculator if we like. I think I did it before. I'll do it again. So we've got 2 times 60 times 60 plus 16 times 60 plus 40. It's equal to 8,200, and that is seconds. Okay. Finally, we need to calculate the speed. So now we can. So speed in meters per second. Speed equals 42,195 meters divided by 8,200 seconds. So therefore, speed is equal to, get our calculator out again, 42,195 divided by 8,200 equals 5.15. Now and that is meters per second. And again, I've just rounded up to 3 significant figures here. Okay, so because the 5 is here, this one rounds up. Okay, so that's our average speed in meters per second, and 5.15 meters per second is equal to 5.15 times by 3.6 kilometers per hour. So the average velocity, or average speed, sorry, in kilometers per hour is equal to 5.15 times 3.6. So 18.5 kilometers per hour. Okay. 2B. How long will it take a cyclist travelling at 35 kilometers per hour to cover 2.5 kilometers? So we have speed, again, equals distance over time. So let's rearrange this. So that means that time is equal to distance over speed. Okay, so we know what. So let's just keep it in kilometers per hour and kilometers because that's consistent. So T is equal to the distance, which is 2.5 divided by 35, which equals, and that's in kilometers, and this is kilometers per hour. So it's equal to, this one too, let me get an eraser. Just erase that, and I'll put it in my equal sign, equals. Okay, so let's get our calculator out. And 2.5 divided by 35 is equal to 0.0714 hours. Okay, that is equal to 0.0714 times by 60 minutes, which equals times 60, so 4.29 minutes, which is equal to 4.29 times by 60 seconds, which is equal to 257 seconds. Okay, so they didn't actually specify the time unit in this one, so we've given them answers in hours, in minutes, and in seconds as well. The next examples have got acceleration in them, so we'll create a new video for those ones.